Today I want to talk about prime factorization. Prime factorization means that every composite number can be expressed as a product of prime numbers. This is called the prime factorization of that number. To prime factor a number, we can use what is called a factor tree. That's going to be the first method that we look at today. So here's an example of a factor tree. If we start with a number such as 36, I can break that number apart into the first two factors that come to mind. So let's say 6 times 6. Then if I look at each of those individual factors, 6 can be broken down into 2 times 3, and the other 6 can also be broken down into 2 times 3. Notice that the 2 and the 3 are both prime numbers. So we can say that 36 is equal to the product of these primes, and if we put them in order, we get 2 times 2 times 3 times 3. Or, more efficiently, we can write 2 squared times 3 squared. Let's try that same factor tree another way. If I take 36, what is the smallest prime number that goes into that 36? Now remember, a prime number is any number that has two unique factors, which are 1 and itself. What if I were to break it down into 2 times 18? 2 is a prime number, so I'm going to leave that part alone and work with the 18 next. So 18 can be broken down in the same fashion. What is the smallest prime that goes into 18? Well, we know that 2 is a prime again, and 2 times 9 gives me the 18. So as you can see, we're keeping the prime numbers on the left, and we're factoring out what's left over. So what is the smallest prime number that goes into 9? Well, we know that both 3 and 3 give me 9, and those are both prime numbers. So if we work with smallest primes, those prime factors will appear down the left side of the tree and will be easy to identify. So again, 36 is still equal to 2 times 2 times 3 times 3, although now they were in order on our factor tree, and we still write exponentially 2 squared times 3 squared. So here's another example. Let's take 100. Now if we go the first way that we worked on, we know that 100 is 10 times 10. And then if we break that first 10 apart, we get 2 times 5. And notice that 2 and 5 are both prime numbers. So I'm done with that 10. Moving on to the second 10, again I get 2 times 5, where 2 and 5 are again prime numbers. So 100 can be factored as 2 times 2 and 5 times 5, or 2 squared times 5 squared. To find the prime factorization of a number, you may also use a method called a factor ladder. In a factor ladder, let's take that same number 36 and begin with the least prime number that is its factor, kind of like we did in that second method on factor trees. So we said that the smallest prime factor was going to be 2, correct? So if we divide 36 by 2, we get 18. And we're going to repeat that same concept until the quotient is prime. So we said that 2 goes into 18, so we're going to divide by 2, and our result is 9. Now again, that smallest prime number that went into 9 was 3, so we're going to divide by 3, and our resulting quotient is 3, which is prime. So we know that we're done. 36 then is written as 2 times 2 times 3 times 3, and again 2 squared times 3 squared. Now let's try factoring the number 60 using a factor ladder. So begin with the least prime number that is a factor. So we know that because 60 is an even number, we could possibly divide by 2, right? So 60 divided by 2 gives me 30. And again, we're going to repeat until that quotient is prime. So still working with an even number, we can divide 30 by 2, and our result is 15. Now the smallest prime that goes into 15 is going to be 3. So 15 divided by 3 is 5. 5 is a prime number, so we know that we're finished. So we can say that 60 is equal to 2 times 2 times 3 times 5. To write this in an exponential form, we would say 2 squared times 3 times 5.